Your FastMCP server is ready to go, but how do you actually get it running and accessible to clients? We'll explore the two key methods for launching your server: the synchronous run for standard applications and the async run async for non-blocking operations. You'll see exactly how to configure the transport layer, set network bindings, and customize logging, all with just a few lines of code.
Configure transport when running. MCP run. Transport equals HTTP. Host equals 0,0,0,0. Bind to all interfaces. Port equals 9000. Custom port. Log level equals debug. Override global log level. Or for async usage. Await MCP. Run async. Transport equals HTTP. Host equals 127.0.0.1. Port equals 8080.
This demonstrates the transport abstraction pattern for server deployment. The pattern separates application logic from communication protocols, allowing the same server implementation to run over different transports like HTTP, SDDIO, or SSE without code changes. What makes this distinctive is the runtime configuration of network behavior rather than hard-coded transport dependencies. The approach works by deferring transport decisions until execution time. Your server defines capabilities through tools and resources, while transport-specific parameters like host, port, and protocol become configuration options passed during startup. This clean separation means you can switch between local testing and production deployment by changing just the run parameters, not the server code itself. This pattern matters because it solves the classic deployment flexibility problem. You build once and deploy anywhere. The same server can run as a local CLI tool, a web service, or even a proxied endpoint. The trade-off is a slight runtime configuration overhead, but it eliminates transport-specific boilerplate and makes your server truly environment agnostic. Let's break it down line by line.
Configure transport when running. MCP run.
This is the entry point to start the FastMCP server. The run method blocks execution, handling incoming requests until termination, making it the standard pattern for synchronous server operation.
Transport equals HTTP.
Specifies HTTP as the transport protocol for the MCP server. This determines how the server communicates with clients, using standard HTTP requests and responses instead of alternative protocols like WebSockets or gRPC.
Host equals 0,0,0,0. Bind to all interfaces.
Binding to 0000 exposes the server on all available network interfaces, not just localhost. This is essential for production deployments where external systems need access, but defeats security by default for local development.
Port equals 9000. Custom port.
This explicitly sets the server's listening port to 9000, overriding the default. Critical for production deployments, where you need to avoid port conflicts or match infrastructure requirements like load balancer configurations.
Log level equals debug. Override global log level.
This overrides the global logging level for this specific server instance, forcing debug output regardless of the application-wide setting. Critical for diagnosing transport issues, connection problems, or request handling during development without permanently changing the global configuration. Closing parenthesis terminates the method call, finalizing the server configuration. Without it, Python raises a syntax error, preventing execution. This is standard Python syntax, not specific to FastMCP.
Or for async usage. Await MCP. Run async.
This is the async entry point for FastMCP. The await runs the server asynchronously, enabling non-blocking I/O operations for better scalability under concurrent loads. Use this variant when integrating with async frameworks like FastAPI or when handling high concurrency workloads.
Transport equals HTTP.
Specifies HTTP as the transport protocol for FastMCP's server. This determines how the server communicates with clients, with HTTP being the standard choice for web-based AI tool integrations.
Host equals 127.0.0.1.
This binds the server to localhost, restricting access to the local machine only. Critical for development, it prevents external network exposure while allowing local testing. Contrast this with 0000, which exposes the server to all network interfaces.
Port equals 8080.
Specifies the network port for incoming connections. Port 8080 is a common alternative to 80 for HTTP services, often used in development to avoid requiring root privileges while maintaining compatibility with standard HTTP tooling. Closing parenthesis terminates the method call, finalizing the server configuration. Without this, Python would expect additional arguments or raise a syntax error. Transport configuration pattern. The HTTP transport configuration in FastMCP 2 defines how your server listens and responds, with host binding and port selection determining accessibility across networks. Binding to 0000 exposes your server to all network interfaces, while 127.0.0.1 restricts it to local connections only. Always verify your firewall rules when changing host and port settings in production environments.
The server that listens everywhere hears nothing until it is called by name.